Here are the answers for the Chapter 9 review sheet. Number 1, write this radical expression in exponential form. Inside of the radical is the base. So you copy that down, xy to the 5th power. Then look at the index of the radical. That becomes the denominator of a fraction exponent. So put parentheses around that base, and the exponent is 1/4. Number 2 is the reverse. This time we have an exponent expression. We're asked to give radical form. So this number here in the parentheses is the base of the exponent. That is the radicand in the radical. So we have the 5th root of, and then the 3ab squared. Notice how the denominator of the fraction exponent becomes the index of a radical. Number 3, we're asked to simplify this. This is a multiplication problem, and these have the same base. So we learned the rule in an earlier chapter. To multiply powers with the same base, write the base, and then add together the exponents. The square root of 2 plus the negative square root of 2. That happens to make a 0 up there. And any number except 0 raised to the 0 power is equal to 1. Number 4, we're asked to solve an equation, but the variable is in the exponent. In this equation, the base is the same on both sides. So if powers have the same base and those powers are equal, then their exponents must be equal. So we can write m equals 2m squared minus 1. Then solve this equation for m. Well, this is a quadratic equation because of the highest degree 2, and we know that you solve a quadratic by making standard form. So subtract the m to get a 0. 2m squared minus m minus 1 is equal to 0. Now we can solve this using the quadratic formula, using factoring, or whatever way will work. I'm going to try factoring. Trinomials factor with a double parenthesis pattern using FOIL. 2m times m is the 2m squared, and then because this is a 1, it has to be 1 times 1, and then we'll put a negative sign here and a positive sign here. The reason is that positive times negative makes this negative, and the outer product is negative 2m, and the inner is positive 1m, and those add together to make negative 1m. Now that we have factored form, use the zero product property to set each factor equal to 0. So 2m plus 1 equals 0, or m minus 1 equals 0. And solve each of these. M is equal to negative 1/2, or positive 1. Number 5, we're asked to graph this equation. This is called an exponential equation. And all equations can be graphed by making an xy table, choosing numbers for x, plugging them in, and finding the answers for y. One of the numbers you should choose is 0. 2 to the 0 power makes 1. Another number you should use is 1. 2 to the 1st power makes 2. Let's also use 2 for x. 2 squared makes 4. We don't want to forget negative numbers for x. So let's use negative 1. 2 to the negative 1 makes 1/2. We could use negative 2 for x also. We would get 1/4. Be really careful with your negative exponents. When you have a negative exponent, that creates reciprocals. It doesn't create negative answers. Let's graph these dots. Left 1, up 1/2, then 0, 1, 1, 2, and 2, 4. There's room on our graph. We could have even used x equals 3 and done 2 to the 3rd power is equal to 8. That dot will fit on there too. Start alongside the x-axis and draw up through the dots. Make sure you're being very accurate, that you're not just slopping a curve on there, but you're actually using an XY table to find where the dots go. Number 6 is also an exponential function, but this time the base is a fraction. I'm expecting a curve like the first one, but a curve that will go downhill. Let's make an XY table. And make sure you choose 0 as one of your x values. So 1/3 to the 0 power is equal to 1. We could use 1 for x. 1/3 to the first power is equal to 1/3. If I choose more positive numbers, I'm going to keep getting smaller and smaller fractions. Let's use a -1 for x. 1/3 to the -1 makes 3. And if we used -2 for x, we would have 1/3 to the -2, which makes a 9. Let's graph these dots. Left 2, up 9. Left 1, up 3. 0, 1, and 1, 1/3. Draw through the dots. And get close to the x-axis. Make sure when you get down here that as you travel to the right, you're getting close to the x-axis, that you're not bending it back uphill. If you start to bend it back uphill, now your graph is wrong. Number 7, give the inverse of this relation. To give an inverse, you switch the x and y coordinates. So the first ordered pair when you switch becomes 4, 2. The second ordered pair becomes 7, 3. And the third ordered pair is 10, 5. Number 8, write an equation for the inverse. Again, to make an inverse, you switch the x and y. So we have x equals 1/3 y plus 2. Now this equation is the inverse, except it's typical in an algebra class to take whatever equation that you create here and rewrite it so the letter y is alone. So to do that, let's subtract 2 from both sides. We have x take away 2 is equal to 1/3 y. Then we need to get rid of the fraction in front of y, multiply by 3. So 3x take away 6 is equal to y. It would be a good idea to just switch the sides. Y equals 3x take away 6. We do that because that makes slope-intercept form. And if we ever had to graph it or make an XY table, that would be the best form to have. Number 9, we're asked to evaluate this logarithm. Log base 5 of 125. What's it equal to? We want to find this number here. We don't know what it is. You could put a variable there if you want. To evaluate a logarithm, you take the base and you raise it to an exponent to equal the argument of the logarithm. 5 to what power equals 125? 5 to the third power is 125. So the answer for x is 3. Back here on the original problem, we were trying to say what this is equal to. It's equal to 3. You ask 5 to what power makes 125? Number 10, solve for the x. This time the x is the base of the logarithm. So the base raised to the 5th power is 32. What is the answer for x? You take the base, x, you raise to the 5th power, and that equals the argument of the expression. What number to the 5th power is 32? That's x equals 2. Number 11, find the value of x. This time x is the argument of the logarithm. Take the base, raise it to the -1 exponent, and that equals the argument. Well, 10 to the -1 is the reciprocal of 10, 1/10. Or if you prefer a decimal, 0.1. These three questions, 9, 10, and 11, get at the meaning of the different components of a log expression. Number 12, what is the base of the common log? The logarithm where you just write the word log and then you don't put a little number in the corner at all. That's automatically base 10. Number 13, use a calculator to evaluate log of 0.62. You are literally pressing this button on the calculator, the one called LOG, and then typing 0.62. This is equal to negative 0.207. Because the next number after 7 is a 6, you might write this as negative 0.208. But I would take either one of these on a test. Number 14, use a calculator to evaluate the anti-log of this number. Anti-log also is log inverse. A little -1 in the upper position means inverse log. But on our calculators on our desk, anti-log is the button 10 to the x. You're looking for that button. It's actually the same one as the log button, but you got to push that second button first to make it work. When you push the button, on the screen will be a 10, and in the upper corner, put the 1.4362 in as an exponent on the 10. Then when you push enter, it'll be 27.302. This actually goes out really far with the decimal places, but the direction said give it to 3 decimal places. Number 15, condense the expression. When you have a logarithmic expression and the base is the same on all the logarithms, the adding and the subtractions can be condensed into a single log expression. So you write log base 2, and then you figure out what the argument of that single expression is. When you have adding, these two arguments get multiplied. When you have subtraction, this argument gets divided. So here is the condensed version of this original expression. The adding part of it converted into timesing of the 3 and the x. The subtraction part of it turned into dividing of the y. Okay, number 16, the reverse process. Let's expand the expression. So we have log of the 3, then plus log of the a squared, then minus log of the b. That timesing right there, when you expand, converts into a plus sign. This division right here, when you expand, converts into a subtraction. Number 17, write as a product. When you have a log expression and the argument of the expression has an exponent, that exponent can be brought out in front as a coefficient of the log expression. So this is equal to 5 times the log base 4 of m. Next, here is the compound interest formula, and number 18 is a question about this. So my suggestion is you read through the sentence and you label what's what in the formula. An investment will pay 2% interest. So take the time to write R equals 0.02. Be really careful with your percents. On a calculator, when you have a percent, you have to put it in the calculator in its decimal form. So 2% is 0.02. Then it says compounded monthly. So take the time to go n equals 12. 12 times a year is what monthly means. What will be the future value? So future value is the letter A in the formula, meaning the amount in the future. Then it says after 5 years. So T equals 5. If you deposit $1,000 when you start, that's your principal investment. How much you put in there to start the investment. So P equals 1,000. Now that we've identified all the values, we can substitute. A equals, fill in the 1,000, 1 plus, for the letter R, put in 0.02, For letter N, put in 12. And now our exponent, 12 times 5. Now you have to figure out how to best type this in to get an answer for your unknown variable. Well, the unknown variable is on the left side, and it says it's equal to all this stuff over here. Well, this is really nice because our calculator can handle this kind of work. You can type in on your screen exactly as you see it if you're careful with the parentheses and you're careful that in the exponent you make it be 12 times 5. All right, well, the answer with a dollar sign, since this is about money, is $1,105 point and then 0.77 cents. The next number is an 8, which is 5 or higher, but with an investment, you don't actually round that upwards because an investment's not going to pay you an extra cent that you haven't really earned. Number 19, same formula, but different information. An investment will pay 3.5% interest, so R equals 0.035. You have to be so careful when you're changing percents into their decimal version. Take the dot and go 2 places to the left. Or another way to think of that is divide by 100. Compounded 6 times per year, so N equals 6. How many years will it take? That's the letter T, so our unknown is the T. And that says for a deposit of 500 to double in value. So the deposit of 500 is what we put in there as our principal to start it. So P equals 500. The phrase double in value means in the future we want A to be 1,000. Let's make those substitutions. 1,000 equals 500, parenthesis, and there it is. This time our variable is in the exponent. So we've got to slowly start removing things until we get the T alone in the very last step. As our first thing, let's divide the 500 away. And that makes 2 equals. With the 500 gone, then on the right side, we can figure out everything in the parentheses. So type in the 1 plus 0.035 divide 6 and push enter. That makes 1.00583. And it actually has more 3's, which you can leave on your screen. And the exponent is 6t. We need to solve this equation for t, but the t's in the exponent. This is the purpose of the log expression. Take the logarithm of the left side and the logarithm of the right side. On the left side, when you do logarithm, you're going to get a decimal, but for now you might just write down log 2. On the right side, when you do the logarithm, you take the exponent and you move it out front. We actually had one on our review sheet a little bit earlier that used that skill. Now to get the letter T alone, it's got a 6 in front of it, which you need to divide by, and it's got this log being times to T, which you need to divide by. So T is going to equal the log of 2 divided by the 6 and the log of 1.00583. At this point, it's just a matter of typing this in the calculator correctly. You want to make sure that the calculator knows to divide by the 6 and by this logarithm. So you've got to put parentheses around this when you're typing in. Otherwise, if you just go log 2 divide 6 times log, it's going to divide by 6, but then times by the log. It's not going to know you want to divide by the 6 and divide by this logarithm. And the answer is 19.86 years. Next, number 20, we have an equation. We're asked to solve it for the exponent. And it's not one that we can do in our head, right? If it was 4 to the n equals like 64, then we would know that 4 to the third power is 64. But it doesn't work out that nicely. So we need to solve this with algebra by doing the logarithm of both sides. The log of the left side, the log of the right side. On the left side, take the exponent and move it out in the front. N times log of 4. And that equals log 60. Then think about how you're going to get the n alone. How do you make that log 4 cancel away? Using division. So log 60 divided by log 4. Type that in the calculator and hit enter. This is 2.95 if you round it. Then number 21, we have an equation and it has a logarithm in it already. And we want to solve for x. So we have to get rid of the logarithm. The way that you do this is with the inverse thing of logarithm. And that's called exponentiating. Hey, what's the base of a common log even though it's not written right here? What number goes there? It's a base 10. So what you're going to do is you're going to exponentiate with base 10. You put a 10 on this side and you use the log expression as the exponent on the 10. And the same on the right. You write a 10 down so that the 2 looks like it's an exponent on the 10. This is called exponentiating. When you exponentiate a common log using base 10, that cancels the word log. And you get the x plus 5 alone. On the right side, 10 raised to the second power is 100. You just got to be careful that you do this in the right order. You want to write the 10 down so it looks like it's the base of the power, so that you go 10 squared and get 100. You don't want to go 2 to the 10th. That would be doing it backwards. Final step, subtract 5 from both sides and you get x equals 95.